the calf's metabolism could be programmed by the dam's metabolism.
Welcome back, everyone, to the Dairy Science Digest. This is a podcast designed to bring the Journal of Dairy Science straight to the ears of dairy producers. I'm Reagan Bluell from the University of Missouri Dairy Team, and today we're here to learn about dry cow feed additive that might have potential changes to the DNA of the fetus that she's carrying. And so Dr. Turner Swartz from Michigan State University is here today to discuss his recently released research paper titled The Effects of Prenatal Dietary Rumen-Protected Choline Supplementation During Late Gestation on Calf Growth, Metabolism, and Vaccine Response. And so just with that, we're looking at feeding a protected choline to that transitioning dairy cow and trying to study what is it doing to the calf that's inside of her. So before we dive right in, could you please introduce yourself to the audience?
Yeah, thank you for the invite. I'm excited to be here to talk about choline. My name is Turner Swartz. Like you said, I am a postdoc actually in Dr. Barry Bradford's lab at Michigan State, focusing on transition cow health as well as pre-wean calf health.
Awesome. I bet there are at least a few that are listening in who've definitely heard about choline, but maybe don't really understand what it is. Maybe they've read Balchem's choline advertisements in popular press, but could we pause for just a minute before we dive into the specific feeding project? Can you tell me, what is choline?
Yeah, that's a great question. I think we're still trying to figure out what it does. Choline is kind of like a B vitamin. It's not quite a B vitamin, but we call it a methyl donor. So it provides methyl groups, and those methyl groups can be used for things like impacting DNA. It can be used for other components too, such as impacting functions of proteins and stuff like that in the cow. But choline is also known to help with lipid regulation or lipid mobilization in transition cows. So it's used for lipid export. So that way it helps the cow kind of transition to that negative energy balance in early lactation. So choline has a lot of different effects. We're just trying to figure out what those effects are right now, and we still have a lot to learn about it.
You bet. And really studying in on that. And of course, choline is recommended for humans that are gestating. And so it's kind of interesting to parallel these two mammals side by side and help us better understand. Okay, so there really haven't been many studies designed to study the possible effect of fetal programming or the change of that fetus inside the transitioning dairy cow and the potential of choline to impact that. So let's look in a little bit specifically on your project. We had 67 Paris Holsteins, and you top dressed this corn carrier that had the rumen-protected choline inside of the top dress. And there were two different treatments. Can you explain the two different treatments and then, of course, a control?
Yeah, so we had two treatment groups, a choline that was fed at a normal dose that you would see in industry, which is feeding about 13 grams per day of choline ions. That's about the typical dose we see in industry. Then we fed a little bit higher level. We did 1.5-fold more. So we fed about 20 grams per day of choline ions. The idea there being that if we just might need more, maybe those calves need a little bit more of a boost. Maybe they need a little bit more choline in their dam's diet. So we were testing two different doses, the dose that you typically see in industry, and then a little bit higher. And then, of course, we had our control group that received no supplemental choline.
Very good. And these were fed about 3 weeks or 24 days prior to calving through the first 21 days of lactation. But focusing in on that transition cow and the fetus inside, those details really matter when you're trying to look at fetal programming. So I noticed that you were giving a replacement colostrum rather than feeding the dam's colostrum. Could you explain why you chose to do that?
Yeah, so we gave all the calves a colostrum replacer. They got 300 grams of IgG from the colostrum replacer. And well, the reason why we chose to do that is because colostrum has a lot of variability, right? So we wanted to be able to control for all that variability, give every calf the same amount of colostrum with the same amount of IgGs in it.
Is there anything in the literature that says that choline could help change the profile of colostrum?
Yeah, so I have a paper that got published about a year ago that when you feed choline, you see differences in the profile of the colostrum in terms of choline metabolites. We also see that when we feed choline, colostrum yields go up. Cows produce a
Mhm.
lot more colostrum, but the content of IgG is about the same. So we were doing these two studies side by side. We were looking at the effects in the colostrum. At the same time, we were looking at the effects in the calf. We thought it was a little bit safer just to kind of look at that in utero effect, that fetal programming effect on the calves, and separate that from the colostrum effect.
Yeah,
So that way we could just see what one thing was doing, right? We didn't want to have an interaction going on
the
where we had
extra
more.
noise. Yeah.
Yep, yep.
Uh-huh. Perfect. Very good. And so they got the replacement colostrum, lots of IgGs available there. And then they also got an Enforce nasal vaccine. Do you want to talk about that?
Sure. So one thing that we really struggle with calves is vaccine response, right? Calves just don't respond well to vaccines at all. We're not really developing strong adaptive immune systems. And because of that, we see more disease during the pre-weaning period. So it's pretty common to give an intranasal vaccine at birth in calves that's usually protecting against bovine respiratory disease pathogens. So we gave that vaccine and then we collected their nasal secretions for the next 3 weeks, not every day, but over a 3 week period. And we measured the antibodies produced in response to that vaccine to see if we were altering the vaccine's response related to the choline supplementation.
Because we definitely need to have a robust immune system for those first few weeks of life to make sure those hutch heifers are flourishing. Okay, so we've set the stage. The calves are in the hutches, and you're analyzing not only the blood samples from the calf, but also some blood profiles from that fresh cow. Can you talk a little bit about the energy metabolism on both and what possible interactions that has when fed choline?
Yeah, so choline is known to help regulate lipid metabolism. So it helps with export of very low density lipoproteins out of the liver. It does that in cows. That's why we feed it for fatty liver disease, right? So if you have a farm that's struggling with fatty liver disease, a lot of times your nutritionist might put some choline in the diet to help reduce fat accumulation in the liver. And then those cows can adapt better to early lactation. So there is some interactions there, right? So there is some idea that if choline works better in cows that are struggling with metabolic adaptations to lactation, maybe that could have an influence on the calf.
Mm-hmm.
There's also some idea that the calf's metabolism could be programmed by the dam's metabolism,
Mm-hmm.
right? So if you go through the human literature, you'll see that, if a baby is born from a mother who maybe isn't as healthy, those babies also struggle metabolically. So that's kind of what we were looking at. Like, was the cow's metabolism associated with the calf's metabolism, and was choline altering that response? And we did find some indication of that. We saw that feeding choline reduced markers of oxidative stress, probably improved some health performances because of that.
Mm-hmm.
We also saw that choline reduced NEFA, or non-esterified fatty acid concentrations in the calves, suggesting that maybe there was less lipid mobilization occurring during the first 3 weeks of life.
That was a really cool graph where on figure 4B, where you have the control animals, it's graphing calf NEFA on the y-axis and dam NEFA over the x-axis. And your control animals are just shooting straight up, whereas your choline animals are flat. And it's just really impressive to look at that graph and see a tangible impact.
Yep, you can see that there's a positive association with the dam's NEFA, where you see a nice increase. Where the dam's NEFA increases, the calf's NEFA also increases. And that choline essentially modifies that relationship where it's completely flatline. I agree. It was
just
kind
mutes it. Yeah.
Yeah, it was kind of a neat figure.
I wonder, so there was an improved immune response on these calves. Did you see a subsequent effect on improved average daily gain or body weight?
No, we didn't see an effect on body weight. One of the things that I kind of regret about the study is we measured responses for the first 3 weeks of life. And I think if we would have gone further out and measured responses, and we still can measure responses up to 1 year or maybe even up to age at first calving and get at body weights, then we might be able to pull some treatment effects out there. There's actually a study done at the University of Florida where they show that prenatal choline increases body weights compared to the controls when they reach 1 year of life. So if we kind of get a little further out, we might see that response where these calves born from choline supplemented dams perform a little bit better later in life.
Interesting.
And I wouldn't be totally surprised either if we might actually see a milk response in that first lactation.
Yeah, I wonder. And I know that of the 67, a portion of them were bulls, but do you think there would be a big enough N, or when was this project done? Do those heifers still exist?
Oh yeah, this project was done in 2021. They haven't calved in yet.
I see. Got it. Well, that will be cool to study. And so you guys measured the oxidative stress index in these animals. Could you explain first and foremost, what is the oxidative stress index?
Yeah, so the oxidative stress index is the amount of reactive oxygen species divided by the antioxidant potential. And so what I mean by that is reactive oxygen species are free radicals. And there are free radicals in your bloodstream that can cause damage to your cells. They're free oxygen, so it can cause damage to your cells, cause damage to the host cells. And we tend to see increases in oxidative stress in prewean calves, and we see increases in peripartum cows. And that's because of health issues, and it's also because of metabolic adaptations to either lactation if you're a cow, or even in the calf where their calves are growing rapidly. They're trying to grow very, very quickly. And so their system is stressed. They're trying to grow really quickly. So that can cause some oxidative stress. So we measured that, and we found that in the middle dose of choline, the dose that you currently see being utilized on farm, the calves had less oxidative stress if they were born from choline supplemented cows as compared to the controls. So choline has an antioxidant effect. There's been a lot of work done in the past that show it helps increases vitamin E concentrations, and it's possible that that's part of the reason why.
Fabulous. And really, this is such a challenging time, not only for the cow, but also that early calf pre-weaning. And we know that that's going to be when you will lose some of your replacement heifers. If you're having a mortality loss, that is when it is. And so anytime we can prop up or improve that immune response during that time, that just helps make them a little bit more resilient. Yep. Very good. Well, Turner, this has been very informative, and I want to thank you for your time. And listeners, I applaud you for taking time out of your day to learn how maybe manipulating this close-up cow management could potentially pre-program your fetus in utero for improved metabolism. I've really enjoyed our conversation, and this has been the October edition of the Dairy Science Digest, a monthly podcast project designed to bring the Journal of Dairy Science straight to the ears of producers. We highlight peer-reviewed research articles actively in press, sound science that you know you can base your management decisions around, are provided by your University of Missouri Dairy team. So be sure to like, share, and subscribe to get future editions straight to your cell phone. This has been Reagan Bluell with the Dairy Science Digest, and I hope you have a great